Every culture has asked the same question. How did everything begin? From ancient myths to modern science, humanity has searched for the origin of the universe. Today, we have a theory that explains not only how the cosmos began, but also why it looks the way it does. That theory is the Big Bang. It tells us that the universe was once smaller than a grain of sand, hotter than any star, and denser than anything we can imagine. From that beginning, space itself expanded, carrying galaxies, stars, planets, and life into existence. The Big Bang is not just a story of science. It is the foundation of modern cosmology. It shapes our understanding of time, matter, and the future of everything. In this documentary, we will journey through the evidence for the Big Bang, the mysteries it reveals, and the questions that still remain. This is the story of how the universe began. The phrase Big Bang was first used in the 1940s by astronomer Fred Hoyle. He meant it as a criticism of the theory, yet the name stuck, and today it describes the most accepted model for the origin of the universe. The Big Bang theory does not say that the universe exploded into empty space. Instead, it says that space itself began to expand. Time and matter, energy and space, all started together in a single moment about 13.8 billion years ago. In that first instant, the universe was unimaginably hot and dense. As it expanded, it cooled. Energy turned into particles. Particles formed atoms, and atoms gathered into stars and galaxies. This theory is not guesswork. It is supported by multiple lines of evidence: the expansion of galaxies, the cosmic microwave background radiation, and the abundance of light elements like hydrogen and helium. The Big Bang explains not just where we came from, but why the universe continues to expand today. It is the starting point for modern cosmology. Science depends on evidence, and the Big Bang theory is supported by three powerful lines of proof. The first is the expansion of the universe. In 1929, Edwin Hubble discovered that galaxies are moving away from us, and the farther they are, the faster they recede. This relationship, now called Hubble's law, shows that space itself is stretching. If the universe is expanding today, it must have been smaller in the past. The second is the cosmic microwave background radiation. In 1965, Arno Penzias and Robert Wilson detected a faint radio signal coming from every direction in the sky. This glow is the afterlight of the Big Bang, the cooled remains of the universe's early fireball. Satellites such as COBE, WMAP, and Planck have mapped this radiation with extraordinary precision, confirming the Big Bang model. The third line of evidence is the abundance of light elements. The Big Bang predicts that in the first few minutes, the universe created specific amounts of hydrogen, helium, and a trace of lithium. When astronomers measure the composition of the oldest stars, the numbers match the predictions. Together, these three pillars make the Big Bang the best explanation for the origin of the universe. The timeline of the Big Bang begins with an instant so small that human imagination struggles to picture it. Physicists call it the Planck time, the first fraction of a second after the beginning. At that scale, the laws of physics as we know them break down, and scientists search for a theory of quantum gravity to explain it. After the Planck time, the universe expanded rapidly. This expansion was not into empty space, but an expansion of space itself. Within less than 1 second, the universe was filled with a hot plasma of particles and radiation. In the first 3 minutes, conditions allowed nuclear fusion. Protons and neutrons combined to form the first atomic nuclei of hydrogen, helium, and lithium. This process is called Big Bang nucleosynthesis. For the next hundreds of thousands of years, the universe remained a glowing fog of particles and light. Photons could not travel freely because they constantly scattered off electrons. About 380,000 years after the beginning, the universe cooled enough for electrons to combine with nuclei, forming neutral atoms. This event is called recombination. Light was finally able to move freely through space, creating the cosmic microwave background that we can still detect today. These first seconds and years shaped everything that followed. They set the stage for galaxies, stars, planets, and life. The story of the Big Bang is, in many ways, the story of us. The Big Bang theory explains much, but it leaves important questions. Why does the universe look nearly the same in every direction? Why is it so flat and balanced? To answer these mysteries, scientists propose the theory of cosmic inflation. It suggests that in the tiniest fraction of a second after the Big Bang, the universe expanded at a speed faster than light. This inflation smoothed out the universe, stretching tiny quantum fluctuations into larger patterns that later became galaxies and clusters. It explains why the cosmic microwave background looks so uniform, yet with small variations that seeded cosmic structure. Evidence for inflation comes from detailed measurements of the microwave background, which show tiny ripples exactly as inflation predicts. While scientists still debate the exact mechanism, inflation has become a central part of modern cosmology. It reminds us that even the largest structures in the universe may have begun as the smallest fluctuations in energy. The grand design of galaxies was written in the quantum foam of the first instant. After the universe cooled and atoms formed, matter began to clump under the force of gravity. Tiny irregularities in the cosmic microwave background grew into clouds of gas, which collapsed into the first stars and galaxies. These early galaxies were small and irregular, but over billions of years they merged and evolved into the majestic spirals and giant ellipticals we see today. Dark matter played a crucial role. This invisible substance makes up most of the universe's matter. It does not emit light, but its gravity pulled normal matter into dense regions, guiding the formation of galaxies. By studying distant galaxies with telescopes like Hubble and James Webb, astronomers can look back in time to see how structure formed. They observe galaxies less than 1 billion years after the Big Bang, revealing how quickly the universe organized itself. The growth of structure shows a delicate balance. Gravity pulls matter together, while the expansion of space pushes it apart. This cosmic tug-of-war shaped the web of galaxies that fills the universe. From the tiniest fluctuations in the early universe came the stars that light our skies and the planets that host life. The birth of galaxies is one of the most profound outcomes of the Big Bang. The Big Bang theory explains how the universe began, but it also raises new questions. One of the biggest mysteries is dark matter. Astronomers discovered that galaxies rotate faster than visible matter alone can explain. Something unseen must be providing extra gravity to hold them together. This invisible mass is called dark matter. It makes up about 27% of the universe. Even stranger is dark energy. In 1998, 2 teams studying distant supernovae discovered that the expansion of the universe is accelerating. Instead of slowing down under gravity, space is stretching faster and faster. To explain this, scientists propose that dark energy fills space itself, driving acceleration. It makes up nearly 70% of the universe. Together, dark matter and dark energy dominate the cosmos. Normal matter, the kind that makes up stars, planets, and people, accounts for less than 5%. The Big Bang theory describes how the universe evolved, but the nature of dark matter and dark energy remains unknown. They are the next great frontier of cosmology, and their discovery will reshape our understanding of the cosmos. If the universe began with the Big Bang, how will it end? The answer depends on the balance of matter, energy, and the mysterious force of dark energy. If gravity were strong enough, expansion could eventually reverse, leading to a big crunch, where all matter collapses back into a dense state. If expansion continues forever, the universe could experience a heat death. Galaxies will drift apart, stars will burn out, and the cosmos will fade into darkness. Some theories suggest an even stranger end, called the Big Rip. If dark energy grows stronger over time, it could tear galaxies, stars, planets, and even atoms apart. Observations today suggest that the universe is on a path of eternal expansion, driven by dark energy. But the final fate is still uncertain. What is clear is that the Big Bang was not just the beginning. It set in motion a cosmic story that continues to unfold. The universe has a past, a present, and a future. And we are part of that story. The Big Bang is more than a scientific theory. It is a window into our origins. It tells us that every atom in our bodies was forged in the heart of stars, and that the universe itself once existed in a state of unimaginable unity. By studying the Big Bang, we learn that we are connected to the cosmos on the deepest level. The same laws of physics that shaped galaxies also shaped us. The same particles born in the early universe still move through us today. The Big Bang also teaches humility. It reminds us that our planet is a small world orbiting an ordinary star in a galaxy among trillions. Yet it also shows that humanity has the power to uncover truths written across billions of years and billions of light years. As telescopes like Hubble, James Webb, and future observatories continue to probe deeper into time, they will refine our understanding of the Big Bang. They may even uncover what came before it, if such a question can be answered. The story of the Big Bang is the story of human curiosity. It is the pursuit of knowledge, driven by the desire to know where we come from and where we are going. The universe began nearly 14 billion years ago in an event we call the Big Bang. From a state smaller than a grain of sand, it expanded into the vast cosmos we see today. We now know that the Big Bang left behind galaxies, stars, and planets, and ultimately the conditions for life. It revealed the mysteries of dark matter and dark energy, and it challenges us to imagine the universe's future. The Big Bang is not just a theory of physics. It is a story that belongs to all of us, a story of beginnings, of cosmic evolution, and of the endless journey of discovery. As you look at the night sky, remember this: every star, every galaxy, every breath of life carries the memory of the Big Bang. The universe is not only out there, it is within us. This is how the universe began,